In this video, we are going to look at the conical pendulum. We have a ceiling and we vertical line and we get a pendulum, move it to the angle, say theta, and then you push it into the page and then you rotate in a horizontal circular fashion like this. Okay, so we call this one conical pendulum. From the free body diagram, we can analyze working on the object. We have tension and we have weight. And then I draw it again. So we have tension here and we have weight here. So how can we choose the coordinate system? So we can do the horizontal in X direction and vertical Y direction. And then for the components, I think it's straightforward. We can choose theta. So if here is theta, here is theta. Okay, we have the components of Ty in vertical direction and Tx in horizontal direction. And I think it's quite clear. We can see Ty is equals to mg. Okay, they'll cancel because the pendulum does not have the up and down movement. Okay, so we have two ways to write it. We can write Ty equals to mg, or you can write Ty minus mg equals to 0. Okay, either one is fine. Okay, but we choose the red one. And the other one is Tx. Okay, so Tx, the horizontal components of tension, provides the centripetal force the conical pendulum needs. Okay, so we can have Tx, and this is our centripetal force, and it causes what? It causes centripetal acceleration, ma, which will be mv squared. Okay, and so where is our r? Our r is here, from the center to here. This is our r. Okay, and the speed is traveling will be in the tangent direction will be v. Okay, so this will be our tools of analyzing conical pendulum.